In this video, I'm going to show you how to use the nlinfit function. This allows you to estimate the coefficients of a function, but it's different from something like polyfit in that the function whose coefficients you're trying to find does not necessarily have to be a polynomial. So let's get right into an example. So how about we have a vector x from 0 to 100, and y, which is the difference of two exponentials. Exponential of 0.01 times x minus exponential of 0.05 times x. And then let's also add some noise to make it look a little bit more like real data. So 20 times ran of 1, the length, y. And then let's plot this to see what it looks like. So figure 1, plot x, y. Oh, didn't run that. Okay, so if this is your data, you may not know right away that it is in fact the sum of, or the difference of two exponentials, but after looking at a while, you may come up with an idea that it might be. So then you go to your computer and say, I'm gonna see what those coefficients are. So okay, so the way that you do this is you're first going to have to define a function. You're essentially going to say, okay, I think that this data represents, these data represent the difference of two exponentials. So I'm going to show you two ways to write the function, and the first way is going to be internally. So my fun equals, and then next comes this little @ symbol, which basically tells Matlab that this function is going to be a function of beta and x in this case. So we're going to put our inputs to the function are beta and x, and then we get out a value. But we also have to define our function. So beta, exponential of beta 1 times x minus, oh, I should keep that in there, minus x beta 2 times x. And so there's our function. We can run that, and it prints out to the screen, acknowledges that it's a function. And next, we have to specify our initial guesses. And that would just be the coefficients that we think might be beta 1 and beta 2. Another thing to note is that this beta does assume that you have like a vector with two values in it. So we're going to specify our initial guesses as just initials equal, we'll just start with 1 and 1 and see what we get. Sometimes it's this function nlinfit is pretty sensitive, so you have to vary your initial guesses to get a reasonable estimate. And so the way the syntax of nlinfit goes is you have nlinfit x, y, those are your two original vectors with your data, and then you have your model function, so that's my fun, and then your initials. And then so what this is going to put out is the new coefficients that would be beta 1 and beta 2, and so let's put those in a vector called new co-f's. So let's run this and see what we get. So we got this warning message that said it's ill-conditioned. And what that means is our initial guesses weren't very good. So we're going to have to change those. And instead, let's make it 0.1 and also 0.1. And so we get these two new coefficients of 0.468 and 0.551. And if we're looking back at our actual function, that's not quite accurate, but for the purposes of this example, it's good enough. So the way that you got the coefficients, and now you have to evaluate, well, I guess you don't have to, but now we're going to evaluate our function here with using these coefficients. So we're going to call that new y. New y equals my fun. Then our coefficients, the beta, that's new coefs. And then where we're going to evaluate this function. That's just going to be along x, the same x as before. And so that should work, and I'll run that. And then let's plot it. So we'll have figure 2 plot x, y, and then also x new y, and see what it looks like. So that's what you get, and that's really not too bad. But you know, if you are in a lab, you may want to tamper with it some more. But for our purposes, I think it's okay. Another thing you could look at is the RMS difference. So you could say RMS new y minus y, and you get 7.99, which I mean, it could be lower, but it works for this. Let me know if you have any questions or comments in the below the videos, and yeah, thanks for watching.